Another session of circuits and networks. In today's class 11 under GATE exam, we are going to see problems and solutions on node analysis and dependent sources. So especially we are going to employ KCL to get the solution for different type of problems. Let's go with the first problem. Here you can see GATE 2020 for 1 mark. It was asked that current through ammeters A2, A3 in figure are one at an angle 10 degrees and one at an angle 70 degrees respectively. The reading of ammeter A1 is dash amperes. So answer what you are going to get, you have to round it off to 3 decimal places. So how to solve this problem? Simply you apply KCL at node N, that is incoming currents is equal to outgoing currents. So here the incoming current is I1 and the outgoing currents are I2 plus I3. Just substitute the values which are given, that is 1 at an angle 10 degrees plus 1 at an angle 70 degrees. So both the values are in polar form. If you substitute the values in your calculator, you are going to get 1.3268 plus 1.1133 J amperes. So this answer is in rectangular form. You can convert rectangular coordinates to polar coordinates with the help of your calculator or with the small mathematical calculation. That is, if it are imagine that this is the real value and this is the imaginary value, then under root of 1.32 square plus 1.11 square will give you the value as 1.732, that is a magnitude value with an angle 39.99 degrees. So here, if at all we have to give the answer which is rounded off to 3 decimal places, it would be 1.732 amperes. So this was asked for GATE 2020 for 1 mark for ECE paper. Okay, let us go with the next example. In the given circuit, the current supplied by the battery in amperes is dash. This was asked for GATE 2016 set 1 for 1 mark. So here you can see you have two loops. In fact, the given circuit composes of 1 volt, that is the battery. You have current dependent current source, that is I2 with the direction of the current shown in downwards direction, and that current is flowing in 1 plus 1, that is in 2 ohms. So how to solve this problem? So let me apply KCL at node V. So I have identified a node which is denoted by V and applying KCL. That is the sum of the currents at a particular node is equal to 0. So you have this branch current, that is V minus 1 by 1 plus this branch current as I2 plus V by 1 plus 1, that is 2, equal to 0. Let me frame this equation as 1, and equation 2 you have I2, that is nothing but V by 2. So substituting the value of equation 2 in equation 1, I'm going to get the value of V, which would be equivalent to 0.5 volts. So what will be the value of I1? I1 would be equivalent to 1 minus V by 1 ohm. So that will be the branch current I1. So I1 would be equivalent to 1 minus V, which will be equivalent to 0.5 amperes. So based on this concept, in many examinations, the problem was asked. Let us see the next numerical. In the circuit shown below, the node voltage VA is dash volts. Again, this was the same question which was asked in GATE 2016 set 1 for 2 marks. And the given circuit was like this. Quite similar to our previous circuit, you need to identify the node voltage VA and apply KCL at node A. So I'm going to apply KCL at node A. What I'm going to get, I have this branch current, I have 5 amperes coming towards node A. Again, I have a branch current which is VA by 5 and VA minus 10 by 10. So this is what I have framed as equation 1. VA plus 10 I1 by 5, well, that is one branch current, plus VA by 5, this becomes another branch current, plus VA minus 10 by 10 becomes another branch current, and another source current which is coming towards node A, that is minus 5 equal to 0. In fact, what is this I1? I1 is nothing but VA minus 10 by 10. So substituting equation 2 in equation 1, I would be getting this equation VA plus 10, I1 is VA minus 10 by 10 plus VA by 5 plus VA minus 10 by 10 minus 5 equal to 0. Just reframing this equation, I'm taking VA terms on one side and constants on one side. So I'm going to get VA plus this 10 and this 10 will go off. We have VA minus 10, so it becomes VA by 5. So VA plus VA by 5, this becomes one parameter. VA by 5 as it is. Then you have VA by 10 placed over here, and here you can see minus 10 by 5, so minus 10 by 5. Here you have minus 10 by 10, minus 10 by 10, minus 5 equal to 0. In fact, you would be having 2 VA by 5 plus VA by 5 plus VA by 10 minus 2 minus 1 minus 5 equal to 0. In fact, you have this VA by 2 VA by 5 plus VA by 5 becomes 3 VA by 5 plus VA by 10. This sum will give you as minus 8 equivalent to 0. In fact, 7 VA by 10 equal to 8. In fact, VA would be equivalent to 80 by 7, which will be equivalent to 11.428 volts. So this is an appropriate answer for this particular problem. I hope you understood how we have framed these equations and how we have solved by taking variations and constants on other sides, and finally we got the value of VA, which is will be 11.428 volts. In the next problem, find voltage V0 in the following circuit. It's a very recent problem, my friends. It was asked in AE exam for TSPS 20th October 2023. On that particular day, this was asked, this particular problem. So this is a problem which was framed. We need to find out the value of V0. So V0 is parallel to 8 ohms. So let me take this parallel voltage as V0, and I have to apply node voltage as V0 as a common node for this particular problem. And the options which were given as 4 volts, 8 volts, 12 volts and 16 volts. Let us see what is the answer we are going to get. Again, I'm going to apply KCL at node V0. Then I'm going to get V0 by 2. V0 by 2, this is one branch current. Then you have V0 by 8, this is another branch current. So towards V0, 6 amperes is incoming, that is why it is minus 6. And this current dependent current source is outgoing, that is why it is plus I0 by 4 equal to 0. So that is one observation. Another observation, what is this I0? I0 is nothing but V0 by 2. So framing these two equations and substituting equation 2 in equation 1, I would be getting the value of V0, which be equivalent to 8 volts. Once I'm done with V0, the given solution from the options is 2 is the answer. If at all in the exam they may ask you to get the value of I0, then I0 would be equivalent to 8 by 2, which would be equivalent to 4 amperes. That is an important note, you need to make a note. Fine. Another question which was framed in Assistance Engineering TSPSC on the same paper for 1 mark, that is finding out the value of V0. Again you can see V0 is framed across 8 ohms. In fact, in the previous problem the dependent source was given, and here there is no dependent source, there are independent sources. One is 3 amperes current source, another is 12 volts independent voltage source. Okay, how to solve this problem? First, let us see the options. Options given as 12 volts, 8 volts, 3.2 volts and 1.6 volts. So for this, I am reframing the given circuit like this. I have this V naught which is present across 8 ohms. So I'm going to take this parallel combination as V naught over here. And you have 3 amperes and 4 ohms which are in parallel. So with the help of source transformation, I can make it to 3 3 amperes parallel to 4 ohms can be changed to 12 volts in series with 4 ohms, and that is in series with 2 ohms. Thereby, I'm reducing this network to a common node network, which is nothing but V naught. And I am applying KCL to this V naught. Let us see what we are going to get by applying KCL at V naught. So V naught plus 12 by 6 becomes one branch current. Then you have V naught by 8, another branch current. Then you have V naught minus 12 by 3, which would be equivalent to 0. So taking V naughts on one side and constants on other side, I'm going to get the value of V naught, which is nothing but equivalent to 3.2 volts. So option 3 is the right answer. So you can see the same concept which was asked in GATE in 2016 for ECE paper. It is repeated for recent exam which was given in 20th October 2023 Assistance Engineering under TSBSC exam. So that's why these concepts are very important. Okay, let us go with the final problem. Here you can see in GATE 2012 for 2 marks, VA minus VB equivalent to 6 volts, then VC minus VD is dash. So this was a problem which was asked in GATE 2012 for 2 marks. The options are given as minus 5 volts, 2 volts, 3 volts and 6 volts. So how to solve this particular problem? If you are looking into this problem, the given values are between VA and VB and VC and VD. So here VA and VB is 2 ohms and this is nothing but VC and VD. 1 ohm is connected in parallel with 2 amperes. 1 ohm is missing over here, but it is a 1 ohm over here. Please concentrate on that. If at all this is the scenario, then between VA and VB 6 volts is given. So the same current would be flowing in the down parameter because the rest of the parameter I'm treating as circuit 1 and circuit 2, and the current which is coming from VA to VB, the same current would be leaving from VD to VC. So what is this current? This current would be obtained with the help of 6 volts which is placed between VA and VB, and the current which is flowing between D and C, it would be 3 amperes. How you got 3 amperes? You have VA minus VB equal to 6, right? And you have 2 ohms. So I would be equivalent to 6 by 2 which is equal to 3 amperes, and that is the current which is flowing over here. So you can get the value of voltage in 1 ohm which will be equivalent to 3, that is the current, multiplied with 1 ohm which will be 3 volts. Now once you get the value of 3 volts over here with the help of source transformation, you have 2 over here, 2 multiplied with 1 will be nothing but 2, and you have arrow mark on this direction, that's why you have positive on this side and negative on this side, and current is flowing in clockwise, that is why we assume here as plus and minus of 3 volts. So VC minus VD will be equivalent to minus 3 minus 2 which is equal to minus 5 volts. If at all same problem would have been asked, what is the current that what is the voltage that would have been developed between D and C, that is VDC, then it would be plus 5 volts. So according to the given option, minus 5 volts is the right answer. So I hope you like this class. Please share among your friends, subscribe to my channel, and please press the bell icon for the future notifications.